one of the issues that comes with BI and with data and data analysis is that we assume that we'll get clean data, but we don't. In most instances, we end up with data sets that have challenges and issues. And I think our biggest problem when we work with it, both as programmers as well as developers, is that we end up spending a lot of time cleaning it up. And then you also have to think in terms of, okay, what can we do to fix it? What can we do to address it? How can we figure it out? What do we do to account for the errors that may be created and caused by that? So now let's start with what is the objective of our analysis? What is it that we want to do? What's the end result and the end output that we want to produce? And how can we use Excel to get there? So our data set has a number of elements and components in it. The end result, the end output is actually two charts that I'm going to show you. Now, these are charts that have been done and have been presented from the perspective of the entire batch. So they're not section wise and they're not component wise. So if I look at my raw scores, for example, this is a distribution of raw scores. This chart, the output that you see here, is one of the desired outputs that I want to work with, and this gives me a grade distribution across the entire batch. So the entire 200 students have been plotted here, and what we're trying to do here is we're trying to get a sense of the batch as a whole perform on an overall basis. So if you see, there are two pieces to this graph. One is the histogram. You've generated histograms in the past. One is the frequency distribution table. I'm going to zoom in a bit so you can clearly see what the frequency distribution table says. When you look at this distribution, the bin is the actual score. So what I've done is your component grades, let's say your quiz grade is 40%, your game jam score is about 10%. So that gives you about 50%. Using that as a basis, you've got a raw score which represents the total score out of 50, and I've scaled that up to 100%. So this 8%, 14%, 20%, 26%, this represents your percentile score out of 100%, scaled up using the total score you've generated as a batch. And then the frequency count is the number of students that fall in that specific bucket. The cumulative percentage is the distribution of those grades. And this gives you a sense of the slices that exist. So for example, the thickest slice right now exists here, which is about at 57%. And you can see it here also. For example, where am I? So if you see this chart, there you go. This corresponds to the slice between 51% and 64%. And then one of the questions that we want to answer as instructors is, what is the grade distribution? So for example, if I say that 5% of the class, or no more than 5% of the class, or 6% of the class, and when I say class, this is now I'm talking about the batch of 200 students, should score an A, that gives you a sense of how many people will score an A. Now 17 is a bit more than 5%. So it's actually about a 5 plus 3.66%. So you're looking actually at about 9% of the class would actually score an A if we do the cutoff at 82 percentile. So this is one possible question that can come up. One other question that comes up is, how has this grade distribution changed? So right now I've generated this for all 3 quizzes and 1 game jam, but how would this distribution change from, let's say, quiz 1 to quiz 2? So this is the output that I've produced. Now, where has this output come from? This output has come from my master list. This master list I've prepared specifically for you, so that you can walk through what I've done and you have a sense of what is it that I've tried to do. If you see the structure, there is a list of ERP IDs. So this is my list of ERP IDs. And this list of ERP IDs is about 199 students in total. There are some challenges with the data here. I haven't done the cleansing piece. I just wanted to give you a sense of what does the data look like. Then I've converted that into a numerical equivalent value using the value function. Then I've looked up the results for quiz 1, results for the week 1 retake. I've done the best of the two. I haven't done anything for quiz 2 here. I'll talk about that also. Then I have quiz 3, then I have a quiz 3 retake, then I've taken the best of that, then I have a quiz average. Then my quiz component is about 40%. My game jam component is about 10%. So this represents the total grade right now as it stands, out of about 50% of your grade. And then I've converted. So for example, this 13.89 represents 13.89 out of 50. This 35 represents 35.67 out of 50. And if you look at the max score is about 41 out of 50. And I think the lowest score is possibly maybe 8% out of 50. And then I've converted this into a percentile score by simply taking this 13.89 and dividing that by 50. And then the last piece that I've done is I've calculated a normalized score. So one of the questions that's come up is, how do you calculate normalized score? The normalized score function, as we discussed in the class and in our earlier conversation, is basically take a specific value and from that value subtract the mean for the data set that you're working with, and then the result that you score, divide that by the standard deviation. So for example, what was the mean for quiz 1? The average score for quiz 1 was about 40% and the standard deviation was 24%. The average for the retake was about 48% and the standard deviation was 22%. So the best would be what? The best was actually the highest score. Then for quiz 3, for the first attempt, the average was 38% and the standard deviation was 18. For the retake for quiz 3, it was 61% and the standard deviation was about 22. And the best was about 57 and 24. And then the quiz average across quiz 1 and quiz 3, I haven't factored in quiz number 2. Quiz average is about 53% and the standard deviation is about 19. And then the quiz component, the average out of 50 is about 21. The standard deviation is about 8. Game jam, the average is about 6. Standard deviation is about 3. Total grade, and this is out of 50, is 27 out of 50. The standard deviation is 9. Total grade in terms of percentile, the average is about 54% and the standard deviation is 19%. Right now, these are standard Excel functions. So for example, if I look at 40 formulas and then click on trace, there you go, and then F, there you go. So that's the average function. And the standard deviation again is a standard Excel function. For example, if I look at the standard deviation of quiz 3 retake, this is again a standard deviation of the entire list. And if you do, there you go. So it's standard STDev of K7 to K205. Why is it that I've calculated these standard deviations? Because if I ever ask you to calculate a normalized score, how would you calculate a normalized score? I think one of the questions that you'd asked is, how do we calculate normalized scores? So for example, here, when I'm doing the normalized score, how am I calculating it? Taken the value for let's say the first item, which is 28%, I've subtracted 54, which is the average, and I've divided the result by 19, and that gives me a value of minus 1.41. Let's say I want to ask a simple question, and that question is, how has the relative distribution of quiz 3, the after the retake, and quiz 1 changed? So I want to take the best of 2, and what I want to do is I want to do the normalized quiz scores for a normalized Q1, normalized week 1, and I want to do normalized week 2. That's the objective. That's what we're trying to do. Compare how have week 1 and week 3 scores changed relative to each other, and this would possibly help us answer the question, are students learning? Is performance improving across the batch? Is the distribution of grades shifting in the right direction? Right? That's the analysis. That's the objective. So one way of doing this is that we have to calculate the mean, the average, and the standard deviation for week 1. and the mean and the standard deviation for week 2. So I've gone out and calculated the mean and standard deviation for both weeks here. Week 1 and week 3, we have this is the standard deviation and mean. I'm just going to highlight that so you can see what I'm doing. So let's say this is week 1, and then this is, because I'm using the best of 2, from our analysis perspective, what we want to do is we want to make sure that we are looking at the final input, right? So now, how would I calculate the normalized value for week 1? The normalized value for week 1 is essentially going to be this value. What is this? This is the number that you've estimated. This is your best of 2 score. And I'm going to subtract what? I'm going to subtract 48. 48 is the mean. Then I lock it. So I press function F4. So you see those dollar signs. Then I open and close the bracket so that I can divide it correctly. And then I'm going to divide it by what? I'm going to divide it by the standard deviation. And this is the standard deviation. Okay. Then I'm going to lock the standard deviation also. Right. This is the formula. Now, right now for this specific student, because they didn't take quiz 1, their numbers are 0, and those zeros translate into a z-score, a z-score, normalized score of minus 2.188. This number has essentially come, if you trace the formula, you will see this number has come by this value, which is, so this is xi, the value in question. This 48 is x bar, which is the average, and this 22 is the standard deviation, which is sigma. Okay, so h9 minus h1 by h2. I can repeat this calculation again. For example, let's say for 66.67, what would be the z-score for 66.67? Do you expect it to be higher or lower than 0? Intuitively, what's your reaction? When I convert this 66.67 into a z-score, do you think that's going to be higher or lower than 0? Would it be a positive number or a negative number? So it's going to be higher than 0. It's going to be a positive number. Why? Because the benchmark, the mean for this data set, which is the best of 2 scores for week 1, both the original quiz and the retake, is 48. And this gentleman or woman, 66.67 is higher than 48. How high? You'll just find out. So if I do 66.67 minus 48, then I press function F4, and then I divide the entire thing by 22, which is the standard deviation, and that is F and F4 again, lock that, and there you go. So it's about 0.856585, which is essentially saying that 66.67 is about 0.85 standard deviation away from the mean. So your first z-score for the value of 0 was negative 2.19. Your second z-score for 66.67 is about 0.856585. Okay. And then if I extend this, so it will repeat this calculation all the way down for all 199 students. I'm just going to format this so that's easier to work with and see. There you go.